making you, to some extent, find them within certain categories, like reciprocal or quotient or Pythagorean or even and odd or cofunction. I was also making sure that you said arguments with them, like x's or thetas or u's or, hey, Nathan, you asked this earlier. They can put anything. They can put English letters, they can put Greek letters, they can put, we already did the Greek alphabet, remember? Alpha, beta, gamma, delta, epsilon, blah, blah, blah. Okay. So this is a beta, like a theta, like an x, like a u. I made sure that you guys put arguments in there. What usually happens if a teacher starts quizzing you on something?
It's going to be on the test.
It's going to be on a quiz or a test or a something, right? What's something that you've been quizzed on like I did in some other class, I don't know, this year? Is there anything that any teacher, do you guys memorize things anymore or no? It's only deep understanding and essays. Has anybody quizzed you on anything? Is anybody in physio? There's still lots of quizzing in physio, right? No? No dates in history?
History,
Ooh. There you go, that's a good one. Okay, so think prior. Think in math. Is there anything that you've ever been quizzed on in math before, besides like right now me with the trig identities? Unit circle. I did it this year, you little punks. Remember? Sine of, cosine of, tangent of. Then you quizzed me and I had to come up with it before you could come up with it, or I don't remember how it exactly worked. You asked me and I had to beat someone, or I just had to go fast?
You had to beat someone.
Oh, that was it.
We're the only group agent.
So I quiz you, you quiz me. Unit circle. I need you to know like this. Do you guys know that all the calculus classes today have a huge old quiz coming right back from Christmas break? Not right back. I didn't give it to them yesterday. It was kind of nice. On things that they have to have down. Oops, those are the empty ones. Hold on. Just kidding. Where are the full ones? There they are. On things that are a bit more complicated than just the formulas that you guys just said. Yeah? AB has 50, BC has, I think, 27 plus 50 that they have to have memorized. So are there, I just lost my push pen. Are there things in math that sometimes you just gotta memorize? What's something else from the past? Like go before Precalc, even go before Algebra 2. What's something in the past that a teacher in math has made you memorize? What? Yeah, a squared plus b squared is c squared. That's good. What else? PEMDAS. We just do that value, not just that part, but actually what it means and how you apply it. Order of operations. Ooh, algebra is really struggling with that right now. What else? SOHCAHTOA. Good. Starting in geometry. What else, Lucas? Slope. Y equals mx plus b. That's a form. Sorry. Y2 minus y1 over x2 minus x1. That's good. What else? Maybe quadratic equations. Like with the different forms. Ish. Triangles, the special triangles. With the 30, 60, 90 and the 45, 45, 90. What?
Perfect square.
Perfect squares like 3, 4, 5 and 5, 12, 13 and
It's a perfect triangle.
yeah, no one's gone basic yet. Do you guys
Multiplication
remember?
table.
Yeah, multiplication table. There we go. Nikki's, wow. Okay, there you go. But anyway, yeah, like multiplication tables, right? If you get to a homework problem now and you have to do something like 7 times 8, shouldn't you be praising Jesus and saying, "Thank you, Lord, I know this"? But there are some of you that are still like, "Where's my calculator?" 50 something. Anyway, right? And there are tricks. There are tricks. But doesn't it make life easier if you can come up with some of these things off the top of your head? Like when it's high stakes. But like when you're in a store and you see something like 20% off, isn't it nice if you have some sort of idea of what the actual price is? So it'd be like, it's so cheap, and then you actually do it and you're like, oh, it's really not. It's not worth it. How would you do a quick 20% off? I know you haven't had to memorize it. Oh wow, that's hard. But yeah. Is there an easy way to do 20% off? Some of you are really good at like practical math. My dad's a superstar, but he's never taken calculus. But he can do like quick, like, oh, it's about this. Divide by 5. You could do that. Or multiply by 4/5. Divide by 5 will tell you the discount because 20% is 1/5, right? 20 over 100. You can divide by 5 and see how much money is off, or you can multiply by 4/5 because then you can figure out what the actual price is. Interesting. Anyway, what do you think that big old chart of trig identities ends up being? Really useful to have kind of memorized. Now, there are technically, if you guys want me to be totally honest, there are some that aren't so important. The even and odd are like meh. The co-function ones are kind of like meh. I mean, they'll show up in homework, but they're kind of not super important. But the reciprocal and the quotient and the Pythagorean, they're important. Now here's the struggle. In chapter 5, you guys have a lot more than that table of formulas. Do you guys know that at every end of your chapter, there's like those summary pages before the reviews that we always do? Right? So even though I'm not going to teach you all of chapter 5 today, can I at least show you what's coming? Because some of you, the earlier the better when it comes to memorizing. Especially memorizing where it's not just like for one day, one test, but when it's for the future. Okay, ready? Here's all the formulas that we've done. Yeah, the chart that I just started quizzing you on. And then it's like, oh, no formulas, no formulas, no formulas, 5-1, 5-2, 5-3. We're done with formulas. And then it's like, oh, crud. What's 5-4 and 5-5?
All formulas.
All formulas.
Yay.
Wait, like all formulas. Do you guys see that? Formulas, words. Formulas, 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 formulas. Now, we already talked about how if the teacher starts quizzing you on something like you're supposed to have down, like there's probably a quiz coming, right? But some of you, what was that you? You're just like, can't we just have a note card or a formula sheet or a, okay, the answer is yes and no. Ready? 5.1 says, hey, you can play with trig, it's a thing. 5.2 says, let's go ahead and show you a beginning expression and an ending expression and you try to get there. 5.3 says, now there are these equations where you have to figure out where to go and how to do it, but all of this is fundamental to being able to actually solve. And then this says, hey, guess what? There are more formulas to do this and this and this too. There's really 3 topics in this entire chapter with lots of formulas you're just getting used to. So, this chapter has formulas and problems. Wouldn't it be a brutal test if I made you know all of it all at once? So what do? Split it up. The day before the problem portion of the test, you guys are going to have a formula quiz, and that formula quiz is going to be, well, actually, it's a formula test. It's 25 out of the 100 points for the Chapter 5 test. On that formula test, I am going to literally have it all typed out. I think it's 1 page, but it's pretty squished, and I'm going to have a category like quotient. And I'm going to have 1 or more, maybe all, maybe just 1 or 2, from that category underneath. And I'm always going to give you the left side and ask you to give me the right side. I'm going to give you cotangent of x or cotangent of theta or cotangent of beta or cotangent of something with an equal sign, and you just have to tell me. Remember what category I just said?
Quotient.
So what's the only right fill-in if it's under the quotient category for cotangent of x? Cosine of x over sine of x. Fill it in, you got 100% on that problem. It's just going to be a big old like, and you just fill them in. That's the formula test, 25 points, 1/4 of your entire test score. But then, after you turn that in, the next day is going to be like the actual problem portion. And for the actual problem portion, I'm going to have a printed out from the entire chapter page of formulas that you get to use. Why am I telling you that now? We're working on problems. But I don't want you to think knowing the formulas aren't important. But I want you to realize exactly how you need to have it memorized. You need to be given the left and be able to give the right under a certain category of a formula. But I'm also telling you that when you are doing homework, you should never be stressing of having to pull these formulas out of the sky, out of your brain. You can have always a sheet right next to you that you can be using because that's how the test is. Does that make sense? So what would be a really good idea? Start making on maybe a notebook page, but that's kind of messy, but you could make a dedicated page in your notes, or you could make yourself like an actual formula study sheet, which would be smart too. write out all the 5-1 formulas, have them with you anytime you're doing problems because you're going to have it on the test. But when we get to 5-4 and there are more, add to it and be using those for all the problems. 5-5, add to it. Does that make sense? If you want, go to the end of the chapter, write out all the formulas now. You can be having them with you every single day, studying them and having the practice of, I have a problem, I have a whole bunch of formulas, what do I use? Does that make sense? Any questions on what's coming? I'm letting you know now because that way you can strategize how you do all the homework, how you try to do all the problems, and the exact way you need to be studying the formulas. We're good? Give me a thumbs up. Any questions? Alright guys, it's warm. The middle schoolers are finally back in class. They're not going to be super noisy. Let's get back to writing. This one's a fun one. What's a bummer about the directions though? That's it? Doesn't tell me exactly what to do. It just says simplify. So what did we try doing yesterday? What was the very first step and then we ran out of time so we stopped? We went straight to an identity. Yeah. Yesterday, are your notes open? The earlier examples, we never went straight to an identity. We did something like factoring. Right? We were doing math. Like we were doing math with trig, but we were just doing good old fashioned like algebra, I guess, with factoring. But this one, PEMDAS. Ooh, I brought this up yesterday. PEMDAS. Who's tied together? The sine and the tangent are tied. Now wait, pause. Isn't the beta tied in with the sine? It's an argument, right? It's enough. So technically parentheses. The beta is tied in with the sine. The beta is tied in with the tangent. The beta is tied in with the cosine. But you're right. The sine and tangent are tied in by multiplication, and then you have this cosine over there to the side, right? Okay. Can I do any math? Can I multiply this as is and make it any better? Sin tan beta squared. No. No, beta's in sine. Beta's in tangent, right? Okay. Can I do addition? Tell me why. They're different. They're not like terms, right? So there's no math to do. Okay, fine. Go to your identities. That's a really good trick. If there's no math to do, go to your identities. Notes open, examples we're doing. So there's no math to do. Go to your identities and say, okay, sine equals 1 over cosecant. Ew, gross, no. Cosine is 1 over, oh, no. You're going to have formulas that you could, or identities that you could plug in, but go for what is strategic. Tangent becoming sine over cosine. Aren't you putting tangent in terms of who else is there? So how do we proceed forward? Now is this the math that we can do? Okay, give me something.
Sine squared over cosine.
Whoa! Is Nathan right? Is that legal? Why is it legal? Some of you were like, yeah, duh. Some of you were like, it's over 1. Yeah, if you need that, we have two fractions, multiplying fractions. We just go across. And what happens if we ever multiply something by himself? He squared. And earlier this year, we saw that. Don't get tricked by the trig notation. If we're squaring a trig, it's properly written with a squared in here. It means sine beta times sine beta. Oh. But what else do I have? Okay, what's legal? Can I go like crossing off betas and being like, I have lots of sin? No. But what could I do mathematically, or what should I try? No. We'll ask.
Okay.
Someone's probably thinking.
Are you allowed to put sine squared beta plus cosine squared, or the beta thing all over cosine? Or probably?
You can't just add in something extra unless you subtract it somewhere else, and actually sometimes that's a good thing. But adding and subtracting, I'm not sure will make it easier. You could have changed this. You could have substituted if you take him out. And that would have been 1 plus cosine beta, 1 minus cosine beta if I factor, but I'm thinking ahead. These are all, yes, you could, but would it be helpful? And if you have 1 plus, 1 minus, there's no simplifying, so remember all that's tied. So good idea for future problems. This one, not really helpful. But good idea, because you're weighing your options. You guys are just kind of getting used to things in 5.1. So Emma was going to, hey, let's plug in.
Are you allowed to set?
Didn't help.
What if we set the whole thing equal to 0?
But then you're making an imaginary problem we're not doing. In section 5.3, you might have an equal 0, but if you have an equal 0, well, some of you are like, actually, it'd be nicer. I could subtract, I could multiply. True. But this one, there is more to be done. But do you see the struggle of 5.1? What do the directions say? Couldn't you be like, simpler to me? Who's to say whether you're right or not? So you're just doing what you can. We're doing lots of examples in class to kind of show you directions that you can take. But to some extent, you might be like, whew, it's an odd. Let me go see if I got far enough. Didn't get far enough. I think this one's, the final answer is secant of beta alone. But anyway, you do what you can, then you go check. Wait, what if it's an even? I won't know if I've gone far enough. Do what you can, come in tomorrow, we'll check it. Does that make sense? So don't be stressing about some magical perfect answer out there in the sky. You're just playing and seeing if number 1 you can play legally. Play nice, please. But number 2, if you can go as far as they want you to. Does someone have another idea? I think I cut some of you off.
Maybe like times it
Times
by
what?
cosine.
Yeah. I'm not sure if you, but yes.
And then like that would make it squared.
Yes. Good, Vanessa.
Because like 2 cosine.
Now hold on. Why was Vanessa saying multiply by cosine at all? I mean, that's like bringing in something out of nowhere. No, it's not out of nowhere. What's she thinking? Or what could you be thinking? To get common denominators. So we were doing math there. We weren't doing plugging in. We weren't doing identities. We were just doing math saying we have 2 different, sure, why not? Try to squish it together. So therefore, is she right that that's cosine squared? Yeah. This one's still sine squared. And why am I right to make it one fraction? Common denominators. They combine under one flag, right?
And then substitute for 1.
Sine squared beta plus cosine squared beta is my Pythagorean identity, which is 1. And what's 1 and 1 cosine? Woo! There we go. You guys see it? Now the question is, where would you have stopped? Some of you, to be totally honest, if you were totally honest to me, I'm being totally honest back, would have stopped right here. Been like, I don't know. Couch chat. I don't know. Can you send me your homework? I don't know. Just leave it blank. Who cares? Let's be honest. There are a few of you out there. However, some of you would have been like, okay, I'll try until you're like, then you get stuck. And you're like, whatever, tap out. Someone will ask tomorrow. Or couch chat, but would you keep trying and playing things to see if you could get it to be nice? Is every single homework problem going to get down to be like that? No. But Nathan a second ago said, what if we just, in section 5.3, this is coming. And how do we solve this? We can't unless we get it to be something simpler using our skills we're developing now. Now we can say, ew, gross. Actually, no, I don't like that. Even though it's prettier, I like this because cosine in my head is way easier than secant. And then I would say, ha-ha, multiply. Uh-oh. I think this problem can't be 0. That's right. Secant jumps and never hits 0. That'd be an impossible problem. But maybe we would have something like, I don't know, equals 2. That's possible. I could multiply up. I could divide cosine equals 1/2. So much easier if I could just change what it looks like. And with trig, we can't. And there's something in calculus BC, oh my goodness, the highest level of math most high schools offer, called trig substitution that takes an impossible, what we call integral. John's just learning it, like we just started it in BC yesterday and today. And trig, if you can take something with x's and say, it's impossible, and then bring this random trig in from nowhere. Trig we can play with because of all these identities, whereas x's we can't sometimes. Kimia.
Can you do a homework problem?
A specific one?
Yeah.
Can I just zoom through some examples and then we see if it matches up? What does it look like though? I'll come look at it. You guys, I want you to peek out this one and say, oh, wait a minute. Didn't Vanessa a second ago say that we should get common denominators? Some directions actually tell you to get common denominators. So, how would you have gotten common denominators? We practiced yesterday.
Number 23.
You see it? So x squared minus 1 would be x plus 1, x minus 1. You just have trig. Is this easier or harder common denominators than the ones that we just did? Harder, because they're pluses and minuses and secants, and I hate those, and they both have denominators. Ugh. So go back. So what if you had seen something like this when you were an itty bitty kid? What would you have done? Multiply by 3, multiply by 2, multiply by each other. Good job. So, what are you going to do down here? No, they're so close. Can't I just pretend it's a minus? But multiply by each other. Some of you are thinking of multiplying. That's good. I'm going to use that. For some of you, it would make life, or it will make life, so much easier if you learn to limit the complaining and instead channel that into trying. What do we get? Why is it legal for me to go ahead and take what Nathan's saying up here about secant squared of x minus 1 and make it one big fraction when just a second ago I had 2? Same denominator. I'm allowed to combine. Sweet. Why am I going to rewrite this one? Not stressing about parentheses, even though in math parentheses are pretty stinking important. I even have a poor little seal that dies if you don't use them right. But why do they disappear? It was multiplied by what kind of number? A positive 1? And what happens to signs if I multiply by a positive 1? Yeah, stay the same. But what do I have to be really careful of right here with this guy? And I have to make sure that I distribute. And if I'm not going to distribute, I should have probably written minus 1 with parentheses and then done that in the next step. Some of you, this is enough to keep going and see how far you can go to simplify. Emma, what's that?
Why can't you just distribute the negative from the beginning and make secant x plus 1?
I love the idea. Technically, this negative, when applied to a fraction in any way, shape, or form, is either going to give me a negative over a positive or a positive over a negative. If I was to take a negative to an entire fraction and bring it in, I either need a negative on top or a negative on bottom. So I just brought it on top and distributed it. But what Emma's thinking is, why not just bring it on bottom? It'll change the sign. So will it make it a plus? Yes, but because I need to distribute, it will also make it a minus, and I'm still in trouble. But great idea. It could have happened. It just wouldn't have helped. We got math to do, yeah?
Why is it minus? Should it be plus?
So easy to kill seals. With your straws or your math. Oh wait, those are turtles. Anyway, secant squared minus 1. I think that's I forget who said it. Was that you, Spencer? Yeah. Tangent squared. Now, guys, those Pythagoreans are really easy to get confused And this is why it's awesome that whenever you do problems, I've already told you to have the formulas close. You're allowed to look at them. You don't have to just be like, I think it's tangent squared. Make sure it's tangent squared, because every now and then they're going to give you 1 minus secant squared. You're like, it's tangent squared. When it's a negative, you got to be careful. So, is secant squared minus 1 a positive tangent squared? Yes. What do you think the back of the book? It's an even. Shh. What do you think it would have as its final answer? Stop? I don't think so. What do you think they would have done? Aiden, this one's yours. The reciprocal property. 1 over tangent becomes what? But it's a squared. No problem. Dun, 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 dun. Yeah? Now the last 2 examples, okay, they were kind of, what do you call them, misnomers? Because they both came down to one nice little, hey, it's so pretty. Well, it might not be pretty, but it's simpler. Once again, it doesn't always happen that way. But if you get something like this, you're like, hey, I think I did pretty well. And you did. And you did. Are we okay? This one's giving us something particular to do. Remember, this is building our skills, showing us what we can do. So if it says substitution means take an equivalent statement and plug it in, right? Where's our equivalent statement? Where are we putting it? So easy, and yet on every Chapter 5 test, so many people mess up this type of problem. Ooh. Anybody have a highlighter saying I just said this was a test question? Or at least similar to one. But I tell kids that every year, and they still mess it up. So easy and it's so hard. Walk me through. I'm just a puppet. I have a marker. You tell me what to do. This is what Nathan said, in case you guys are curious. Sorry. No, I'm a puppet. I'm just doing what you tell me to. So I wrote square 3 cosine theta. Oh. Okay, now what? Verbalize. I can't hear you. Neither can they. What? Say it loud.
Killing a puppy.
Wait.
I have a puppy.
Oh, it's so cute too.
Wait. Why? Because you can't look at the square root of this. Why?
Well, because the 9 wasn't squared.
It's not square root times, it's square root of. Distributing a square root is totally illegal because isn't this is that a perfect square? They're different. Took Justin a little bit to have the confidence to say it, but yes, I'm backtracking. I don't want to kill my puppy. Or yours. So was Nathan right?
Yes.
Okay. So now what? Okay.
Imaginary.
This This is what Justin just said. Distribute the squared.
Wait, what?
Talk.
So,
This is the
radical 9 minus. Wait, what? How do you distribute cosine squared? Wait, what? What?
Why is this legal? If I can't distribute a square root, how can I distribute a power? Technically, it's not distribution. Technically, it's multiplying 3 cosine theta times 3 cosine theta. But in essence, we kind of call it a distributive property of exponents because if you have a term with like constants and variables and expressions, if you write it next to each other, every piece of that product is going to get the power. So distributing, technically, yeah, it's called the distributive power of exponents, but it's not an illegal form or use of the distributing word. So now what? 3 minus 3 cosine theta. No, puppy, dead. So now what? You're not done. 9 minus 9 is 0, and then it's square root of cosine squared, so then it's cosine. You killed, I don't even know what. PEMDAS. You killed PEMDAS. That's tied. That's tied, right? Yeah, your Aunt Sally. She's the one. Sorry. It's tied. You really have an Aunt Sally. So sorry. Now what? Can't do that. Can't do that. Good.
Oh. Could you simplify, like take out the 9 and make it 1 minus cosine squared?
Justin, your way would have worked too. It just would have been a little bit more work for the 9s to cancel. Distributive properties of exponents. I was allowed to distribute the squared when there was multiplication. I'm not allowed to distribute the 1/2 power. The square root is an exponent because of the addition or subtraction. I'm not allowed to distribute the 1/2 power here, but I am allowed to distribute the the square root with the multiplication. But the problem is that just gives me a we factored out a 9. That can be I'm not stuck with the minus anymore. Because using the Pythagorean property. Some of you got this earlier and didn't tell me. 3 sine theta. And if you want to be super snazzy, there should be an absolute value because square rooting a squared always ends up in a it needs to stay positive. Woo. Now pause. Do you see why a lot of kids miss this on the test? Maybe it made sense just now, but then give yourselves a week or two. You're going to make the exact same mistakes all over again. So we need to be careful of killing puppies. We need to be careful of squaring, possibly, expressions, maybe even just plugging in to begin with. Using a property, but guys, have you highlighted this one? It's tricky, but it's good. Wait, so we're done? Can I show you why we did 5-1 just for 1 second since we have a couple minutes, and then I'll see if there's any tricky homework problems you guys want to talk about? Don't worry about that. Don't worry about that. Okay, hold on. Mrs. Regan's favorite type of problem. Come down. Come down. Emma, come down. Okay. This is section 5.2. Okay, not 5.1. 5.2. But the 5.1 skills enable us to be able to do 5.2. Which is still building skills for 5.3, the equations with like equals to numbers and unit circles and all that stuff. Okay. What's the word that you see? For all of section 5.2, the directions are verified. Where I want you guys, well, the honors pre-cal kids, when they came back from break, we took a huge old day to just review 5.1, 5.2, 5.3, because they're picking up with 5.4, 5.5, they have a test next week. But I asked them to summarize what they had learned in chapter 5 before break. And when we came to section 5.2, there were 2 words, verify and t-proof. That's what they remembered. It was perfect. Because the point of this is not to say, like, let's use it. The point of this is to say, I could get from here to here, and I'll show you how. That's the point of 5.2. I could get from here to here, and I'll show you how. Or I could get from here to here, and I'll show you how. That's all 5.2 is. It's called T-proof because I force you guys to draw a T. Why? Because you're not allowed to move these back and forth. The point isn't can you get rid of everything. The point is I could go from here to here. The nice thing about 5.2 is they're telling you what they want you to change it to. There is no more guessing. There is no more how far do we go. Instead, there's a I can do it and I'll show you. But there is a choice. Even though they give you an equals, if you guys know the totally just blew out of my mind. If A equals B, then B equals A. Is it the commutative property of equality? Anyway, if A equals B, then B equals A, we can technically look at this equation as starting here, ending here, or starting here and ending there. You get to choose what side you want to play with. But I'm going to choose this side to play with. I'm just showing you like a 5.2. I'm going to choose that side to show and develop and basically show off my skills and say, yeah, I can make a match. Because I see that he has a sine squared, so I want him to stick around, and I see a cosine squared that I'm like, oh, there's a property for that. Now I'm allowed to have my identities in front of me. However, if I have this memorized, oh man, all right, girls, you party pooper shush. If I have a 1 minus a 1 sine squared minus another 1 sine squared, what's a minus 1 minus 1? This is like one of the easiest ones ever. Check, QED, quote, error, demonstrative, Latin for thus it has been proven. I showed you how that is that one. And you'll probably make me use it later. But for right now, all we have to do in section 5.2 is show how one becomes the other. And you might be like, okay, that's easy. I think it's a little, oh, never mind, that's just complex fraction. A little. But do you see how all of these are showing you where to go? So what's nice about section 5.2 is you'll know where to go. And you'll know whether or not you got there, which is actually the most frustrating part if you can't get there and if you get stuck. In section 5.1, to some extent, enjoy not knowing. Because unless it's an odd, do you know exactly how far you're supposed to go? No. So focus more, not on getting to the nicest, simplest, easiest, littlest answer. Instead, just focus on keep it legal and go as far as you possibly can. Does that make sense? All right. Start making that formula page. That's my advice. When you do problems, have your formulas in front of you. That's my advice. And be building your skills tonight. But pause. Am I challenging, to some extent, your guys' understanding of PEMDAS? Yeah. Distribution. Yeah. Factoring. Common denominators. Simplifying. Reducing. Watch out tonight for the little stuff. Sound good? I'm done. You guys hang out, check in with each other.